said good luck. So with this resolution, I need some luck. So what's my name? Adam Bean. I really like Java, work with Java. It's what I do. On the back end, Java 8, and on the front end, usually JavaScript with HTML5 plain or React or something like this. But now let's focus on the back end. So the idea to the talk came last year, so lots of startups, and I actually provide some consulting for startups. And it's not like you think that they come to me and say, please show us Java EE, it's a great technology. It's more like they come and say, okay, we would like to implement something like this, what you would do. And without any introduction, I show them a hack example, what I will do right now with Java EE, without mentioning actually this is Java EE, and the feedback was actually great. And okay, I've read some blogs and so forth, but we have to save time. So, oh, this is the most important slide. If you have some questions, the first Monday of the month, you can ask me and I will answer it live, or you can write the question or the gist. Some workshops. And this is the slides I created. So, what is the most important things? And actually, it is very similar to the enterprise development, but the priorities are different. I would say time to proof of concept, not necessarily time to market. Usually, the startups would like to develop fast because they would like to show something to the sponsor or whatever. Time to market is nice, but usually what counts is proof of concept. And surprisingly, Java EE, what I show you right now, is actually 0. So there is no setup required, no evaluation. You can start right away. And I guess this was the first thing where I was able to convince fresh startup developers to use Java EE to show how easy it is to start. Then the next one, vendor neutrality. So in one startup, we started with Payara. They were not happy because they had more experience with Whitefly. So we switched without any migration to Whitefly. We proceeded with Whitefly. And in one project, we used Tommy, but we experimented with Payara. And why it's great? It is great because it shouldn't matter which vendor you are implementing. And actually, startups are not interested in shiny names. They are more interested in the results. So my impression is at least less politics. By the way, as I submitted a talk, they told me, yeah, but this is a startup talk, and you are going to talk about technology. It is actually not compatible. It's like, okay, but I think in Poland, even in Poland, you will have, the startups will have to implement something. You cannot just talk, you have to hack something. So performance and small footprint. This is surprising. Actually, all startups were really interested in clouds. They wanted to, to put from day one the stuff into the clouds. And the cool story is, whatever application server you are choosing, except the old, dinosaurs, but Payara full stack Java 7, Whitefly full stack Java 7, Tommy Plus, Web Liberty Profile, they're actually running on free tier on Amazon Web Services, which we actually did yesterday in the workshop. So I deployed several times to Amazon and took seconds to do this. And what means small footprint? An overhead of a microservice running on Java is about 60 megs, so it never mattered. So productivity, so we have Java, so the productivity because of tooling is really great. This is what you have to believe me, there's no numbers about productivity. And also surprisingly scalable and rich UI. What it means? Usually, there are actually, so what we did in the startup project, we actually have always two kinds of UI, like a back office UI or admin UI, and like a front-end UI. And the front-end, there were higher requirements from the front-end UIs, and we usually use something like React. And my Angular 2 is a little bit too crazy. So React is great, React Native for native stuff. And the backend was Java EE with Cores. And now comes actually the trick. What we were able with Java EE to do, to hack really quickly the back office UI admins with plain old Java server faces, like prime faces, because no one cared about the pixel perfect. And if I show the startups, prime faces out of the box, they were delighted. There was basically copy and paste code. By the way, it never took off in the enterprises, you will see in the next talk. But it is perfect for startups. Why? Because the admin UI just have to work. Whether it's pixel perfect or not, no one cares, and you are crazy fast. So we had like, two kinds of UIs. One, the shiny customer-facing UI, and the quick hack UI for the back office is usually created with prime faces. And they ask me always, what great technology it is. It's like, yeah, we call it JSF. It's not that great. I mean, if I would come on stage as the new technology JSF, everyone will walk away. But they really like, the idea how it actually worked. Authentication and security, also surprising. I was asked, we would like to have social login. How to do it with Java EE? It's like Java EE actually doesn't support it yet, but there are actually two great open source projects. One is called Keycloak, comes from, it's the same project like Red Hat, keycloak.org, and the other one, very similar one, is OpenAM. And actually, with 1 to 2 hours, you can log in with GitHub or Twitter. It's a social login, and JWT, so JSON Web Token, is supported out of the box. And enterprises using, this Keycloak on OpenAM for single sign-on, and the startups prefer using this for social logins. Or at least they were surprised how easy it worked. Then Stack Overflow factor. What I mean by that? So what I'm using in my projects is no Payara Micro, no Whitefly Swarm. I'm using the plain old, big, if you will, application servers. And the cool story is, because they are so popular, you get your questions answered at Stack Overflow. You don't need, specialist to help you, because it is actually the how to say it, the base technology of enterprises, and millions of developers have knowledge, about Whitefly, Glassfish, Payara, whatever. Just go to Stack Overflow and type in Whitefly, or click on the tag, and you will see how many answers you get. And this becomes less interesting at the beginning. Monitoring. So application servers have great built-in monitoring capabilities. They are RESTful. I will show you in a second. And of course, clouds, microservices, and serverless. So I actually forgot to put my IDE, which is not a problem. I only have to type a little bit. So first, we always used Maven, even in startups, and which is somehow unusual, because you might think, okay, why I'm using Maven? You could use whatever you like, but actually there was no complaints, and let's call it weather. Actually wanted to do something with weather yesterday, but the attendees told me just go with events. So we created a small event sample app. So weather, and the big surprise for Java 7, so I showed it also the last year. So Maven is very short, and it will never grow longer. In particular not in startup case, because the startups developer are more interested in results than in layers, patterns, or whatever. So then, what we would like to do to expose our forecast, PL, I think, Infoshare, weather. This would be forecast, boundary. This is just nice to have, nice naming. Forecasts resource. And the forecast resource is going to create a endpoint. And the endpoint is forecasts. And what I would like to do, I could expose, of course, a string, but string, no one would like to have a string. Everyone is interested in a JSON. So what you usually get, a JSON array. This is what you would like to have. And what you would like to do is to fast prototype. So, well, what usually happens in enterprise projects, architects will kick in and create 20 layers, DAOs, or whatever stuff who no one cares about. So in a startup case, what usually happens, we are more interested in the automation with Jenkins, which I have no time to show you. Jenkins pipeline, automate everything from day one and deliver as fast as possible the first endpoint that we can immediately start, to implement the UI. Because usually you will spend more time in the front end than in the back end. So what is the most efficient way to do this is to expose fake data. So it works like this. So I need a JSON reader. JSON. By the way, what I'm showing you right now is the plain old Java 7. No Java EE 8 features yet. So this is what you already have. It's 3 years old. Create reader. And what I will need is a stream. So I say this dot get class get resource a stream. And the resource is going to be, let's say, for weather.json. So, and what I can do then here, just say return reader read array. So, and this is all. So we stop that. We care about the Jenkins, Docker, clouds, whatever. But we can start with developing, you know, Angular, or Angular probably not, Angular 2, but say React, Polymer, or plain HTML5, whatever, web standards. So if this is done, so what we only need, we need a fake data, which is very easy, or very easy. You need the data, but what was the name? I think weather. Weather, and because we are in Gdansk, it looks to me like it's like Jamaican weather here always. It's hot like crazy in May. So a lot warmer than in Germany. So let's say you have sun and never rains here, right? So sun. This is the usual weather in Gdansk. So this should work. So and now, no Docker. So what I can do, I can say run it. And oh, perfect. So it starts Payara. This is I actually wanted to preload this. It could have some projects from yesterday from the workshops, but so weather, resources, and the forecasts, and it's deployed. And this is actually in one project. I forgot actually the other companies who like I shoot out. They invited me to hack something with Java EE, and the others was a typical cloud provider. I actually forgot who it was. Until they got everything running, we had the full CRUD with system tests and everything was set up. So there were no arguments against. So this is full stack Java 7 with everything is in the Java EE API, and this is also great. So you never ever have to add whatever here in the POM XML. If you're building REST with monitoring, AOP, what else? Configuration, everything is included here, so there is no re-evaluation or whatever. By the way, if you have questions, you can ask me at any time questions. And if not now, after the talk, there's another talk, 1 hour, so we have more time for questions. So now, this runs. What about the overhead? So no one believes me, Java 7 is lean. So what we did yesterday, we measured a little bit more, but because it's fast, monitor stock Java 7 application server with deployed microservice consumes 67 megabytes of RAM. This is the overhead. So I get a question now in startups, are Java application servers not too heavy? We could run on plain JVM with whatever. It's like even if you would run on assembler, right? So you can save, or let's say not assembler. In the assembler, you could actually also you could skip the JVM. But let's say if you would write hello world with JVM, main method, you could only save 60 megs per microservice. So if you have 10 microservices, 600 megs, 106 gigs. Okay, how expensive are 6 gigs of RAM? It doesn't matter. If the startup saw this, okay, forget it. No optimization necessary. If I would start Whitefly, which I will do in the next session, is even smaller. And the smallest is web scalability profile. Okay, questions? No questions. Everyone believes me so far. So now you can say, yeah, it's not the whole story. Who cares about that? We need microservices, clouds. What's the story here? So now, oh, by the way, it already runs. I show you, because it runs, I would like to show you the monitoring capabilities. Monitoring applications. So you can see the weather app is deployed, and there is nothing here because I forgot to make it an Java EE component. So if I write here stateless, you get the monitoring bean methods, and I see the method, the performance of the bean method as HTML. No one cares about HTML, but what always happened, we have this as JSON. So you can scrape the data. What do you get? Back pressure, connection, whatever you have. All application servers have exposed all the data since 2003. J2E management and monitoring. It is mostly forgotten in projects that application servers provide you this monitoring data, which is extremely interesting if you're running with Kubernetes in the clouds or whatever. You need the metrics to have elasticity. And you get them out of the box. Performance of all methods, slowest methods, how many Perl transactions, how many 500s, 4.0, or whatever. So no time. If you would like to see more, ask me after the talk. So now I will kill the my server here. And what's about Docker? And clouds. It's actually the same. So in Docker, I will create a Docker file and say, I don't like to use Alpine Linux. I would like to use a Whitefly full stack. And this is Whitefly 10, the latest version. I built it yesterday in the morning before the workshop. Copy. And because it's Maven, I know that its target weather.war is deployed into deployment dir. So now it's here. I can go to command line. By the way, we always do lots of command line. Why? Because all the commands from the command line become stages in how it's called pipeline as code in Jenkins 2.0. So by the way, Jenkins also a big deal. If I show them that everything is well integrated with Jenkins, there's also on my side. So junk is my folder. Weather, Maven package, and Docker build -t is the tag, Infoshare weather dot. So now everything built from scratch, and we have executable image. So this is that fast, and we can look at the image, Docker images. So some images, you have lots of images, but this is the recent one. Here, and you can see 8 seconds ago, I built Infoshare weather, which is 560 megs, which is a little bit crazy. If you just look at this, it's okay, forget about this. We will never, return a two-slotted JSON array and consume 560 megabyte of disk space. But Docker history, Infoshare weather. If we go here, you see the this is so the font is so big. So what you see here, what you see here is the following. So 8 months ago, I built something, forgot what. 2 months ago, the CentOS 7 was built. 8 weeks ago, JDK was updated, JDK 1.8. 24 hours ago, that was yesterday morning, I built the full stack, so the full Whitefly is 160 megabyte on disk, and now, 53 seconds ago, I created 5 kilobyte WAR. And the cool story is, in all clouds and Docker, the infrastructure is clearly separated from the WAR, and this is the big trick. This is per accident, but this is actually was what developers appreciate. Why? Because build and deployment cycles are crazy fast. So if I will push this to the cloud this year, it will take seconds because I don't have to upload 560 megabytes on each commit. I only have to upload what changes. And the cool story is Whitefly changes 3 times a year. It means I will have about 3 times a year. I will have, to push to the cloud 3 times a year, 560 megabyte of, not what 560, actually only 160 megs, so only the Whitefly to the cloud. But 100 times a day on each commit, I just push 5K. In real-world projects, the WARs is about 500K. If you don't believe me, go to my weblog. I have some interviews with startups and look at the size of the WARs. So now, because it's about clouds, what I did, also we did yesterday, this is Amazon clouds, and we deployed yesterday the Whitefly cloud. So I created already something. And what I prepared, I uploaded the Whitefly and CentOS 7 to Amazon. And if you go here to Airhex Whitefly and view push commands, what happens here? I get actually here my some commands how to push this application to the cloud. So what I actually would like to do. So what I would like to do is to take that and do the following. Go here and say Docker tag first. I will rename my Infoshare / weather into this. No, this is wrong. is hard to get. This is right. This one. This is just straight Docker. And this, by the way, runs on Oracle Cloud, Google Cloud, Azure, doesn't matter. So it's similar technology. Docker tag, Infoshare weather into this. And now Docker push that. Now it's in Amazon. So why? It recognized Whitefly didn't change, CentOS didn't change, and what it was just pushed this war. So what I could do, hopefully it will work, but now it's just, usually it says automated in Jenkins, so we don't do this very often. So we will have to say Whitefly Cloud, create a new task, create new revision, sorry. And it says Whitefly Cloud, this looks good. Wait a second. Oh man. The resolution is. You have to automate everything, so you don't have to play, you know, with the. So we have a new revision, and this is Whitefly Cloud 4. Now I can go to my cluster with elastic load balancing or whatever you have, and say, I would like to update this task, and this is going to be Whitefly Cloud 4 and number of task 1, and then push here the button, and hopefully I push the right button. But the cool story is, what's so interesting, it's not interesting that it runs, it's not a big deal to run it. What I created, the whole cluster runs on T2 Micro. It's the smallest available machine on Amazon. If I would use the one smaller machine, it's impossible to run ECS. So this is the smallest available machine for any container service on Amazon. The Nano doesn't work anymore. It would work, but it doesn't. It runs, I think, with 512 meg of RAM. And it consumes, if we go here, it consumes EC container service. 20% of the memory. And again, no optimization. This is a full stack application server, no micro, no tricks is standard deployment. Okay, now we have it. So what we could do, I will just go to the instance again and ask for the IP address, because I forgot that. This is the public DNS. This is public DNS. So what should work is if I go here and say this 8080. No, it doesn't work. Because I copied not everything. But it works, so should work if I copy the right URI. So we have a few minutes left before I find the URI here. Just do it again. I'm open for questions. So if you have questions, ask me questions right now. If you have deeper questions, I would try with the IP address. It's easy to copy and paste. So this one, 8080. Wow, works. What was it? It was weather, I think, resources, and forecasts. Yeah, because it's Whitefly, this is actually the right answer. And if we go to the and say -h accept application/JSON. So I get sun from Amazon Cloud. So what I did on stage today, I created from scratch with Maven a Java EE microservice, created a Docker image, push it to Amazon Cloud, run it on the smallest available machine without any optimizations. And if I show them to the startups, they get really excited because what they only need, another small machine that already a cluster, elastic load balancing cares about clusters. If you think about this, what I did, the idea is very similar actually to serverless, because you don't care about the infrastructure. You just have an API which is stable, and you're coding against the API. And the only difference is that this API is somehow old, is not very fresh. And if you would use Amazon Lambda or whatever, you would get the API from Amazon. It's not like you will just use Java 8. You will have to use the Amazon APIs. So, and this is the main difference, syntactic difference between serverless ideas. And this is what I did with Java 7. So now, in real world, of course, what you will do, you would put some business logic, and let's say forecaster, and the business logic are just regular POJOs. There are no interfaces, no strange stuff. Say string forecast, and let's say return always sun. So, and then they ask me now, what about robustness and all the patterns, circuit breakers or whatever? It's a good story. So everything is built in. You still don't need any libraries. So what I could do to make it a little bit more stable, I could say, look, this is a asynchronous response, non-blocking response with predefined timeout. And you heard about before about the idea of the new stuff in Java 8 and Java 9 lambdas. So what you can do here as well, increase the robustness. So I can say, you heard about completable future. So you could say completable future supply async this all. And what I'm creating here is an asynchronous pipeline, and if you are done, then accept response resume. And let's say this service could be unstable, so forecast service, I don't know, network problems or whatever. So what I can get out of the box, I can say, I would like to have some more control what happens. And this should run in this thread pool. So I can use, if I have to, dedicated resources for each I/O channel. This is absolutely built in. So you can create as many shared resources I like. So what happens here, this is just executor service, which comes with application servers, executor service. And this is configurable on application server. So you can say, forecast will never get more than 5 threads. And payment can have 50 threads because it's important. What cannot happen, then you talk to one service and this service will kill your microservices. So this is already built in. We don't have time for circuit breaker. I think we have 2 minutes, or 2 minutes is actually enough. So, the circuit breaker would look like this. So we have a breaker. And this is a plain old Java interceptor. Yeah. Invocation context. And by the way, we use it all the time, and we didn't know that the name is circuit breaker, and now we renamed this to circuit breaker. Proceed. So what happens here, we've wrote an aspect which is able to call methods here, but not only this, I can of course check whether the methods are throwing any exceptions. So I can say exception EX and rethrow the exception. So, and now what I will have to do, I will have to count the errors. And on 2, 3, 4 errors or whatever, I will just open the circuit. So how it looks like, so I will need here an atomic, for instance, hopefully the long integer should be enough, counter. 30 seconds to go, no problem. So new atomic integer. Any questions? Raise your hand. So prepare for questions. If counter get bigger than 2, for instance, then return null. Now the circuit opened. And in startups, it makes sense to have more evolved strategy, fallback strategies. In enterprises, we just escalate the error, throw, for instance, a CDI event, and increase, for instance, a counter. By the way, what we also get out of the box, nice integration with Prometheus, for instance, which is a nice monitoring tool with dashboards. This is really easy to expose capabilities to Prometheus and to gather the metrics. So it's also what we did, particularly in the clouds. So, okay, any questions? So I'm done. Questions? Objections? Sorry, I couldn't find, the button fast enough. Otherwise, I will implement the circuit breaker for you. But what I will do right after the talk in the Tech Plus stage, I will proceed with this example and do whatever like. Not do whatever like, whatever clouds related. Okay.
Thank you, Adam, for your speech. Give a round of applause for Adam.